Hi guys, today I'm going to show you how to solve exponentials using logs. Usually when you solve exponential equations, just like the warm-up up here, um, you could take the same or try to get to the same base. I know that I probably have to get to base 5 because that's the smaller number usually, right? And which is true. On the other side, I could get to a base 5 by squaring 5, right? 5 squared is 25. And remember, when we used to solve these exponential equations, you would drop the base, bring down the exponents, and solve for the variable. That was the easiest way we can get to a solution when solving exponential equations. Well, what happens when you have an exponential equation that you cannot get the same basis for, right? So I would try to get 61 to be base of 2, but it would be impossible. I cannot do it. So we use our logs to help us. So as you can see, this equation is in the form of an exponential, and to switch an exponential to a log, you would take the log of your base b of a and set it equal to x. So let's change this exponential equation up here. So this guy up here, let's change him to a log. Okay, to do that, I would take the log of my base. The base in this case is that 2. So log of base 2 of a, that's on the other side of the equal sign, that's the 61, is equal to the exponent x. Okay, and in a calculator, you cannot really change the base on a calculator, so you would have to use the change of base formula. So change of base to solve this. And the change of base formula is just log of a divided by log of b, your base. So in this situation, that would be log of a, in this case the big 61, over log of b, the base 2. That's equal to x. And if you were to put that in the calculator, which I'm going to do right here, that would give me one sec, let me put it in my calculator. That would give me 5.93. So I would say 5.93 is equal to x. This is a possible solution. You have to check your solutions. To check it, just plug what you got for x back into the original exponential equation. So wherever you see x, plug in 5.93. So let's check this. So this gives me 2 to the power of x, but x we know is 5.93 is equal to 61. So I'm going to put that in the calculator, 2 to the power of 5.93, and I want to get a number close to 61. Now we rounded this number, 5.93. It was a much longer decimal, so instead of writing the whole decimal, I rounded it to the hundredth, right, place, decimal place. So your answer is not going to be exactly 61, but if it's close enough, right? Close enough means if it's in the area of 61, then that's a solution. If it's not, if it's super far off, like if your answer is 100 numbers off, obviously that's not the answer, right? That's not the solution. So let me check it in the calculator, and I could say yes, this is a possible solution. It gets me close to the number 61. So we're done here. Okay, let's try another one. So let's try number 5. In order to change this exponential to a log, you have to get it in its simplest exponential form. This is not in the simplest exponential form. I have an extra 4 right here. To get rid of this 4, right, this 4 is being multiplied. This is a multiplication symbol. To get rid of it, you have to do opposite, divide. Since it was being multiplied, opposite is division. That way we can cancel the 4 in the front. Now I have 7 to the n power is equal to 148 divided by 4 gives me 37. Okay, now this is in its simplest form. Now I could change it to a log. To change to a log, you just take log of the base, in this case it's the 7, of the number 37 right there on the right side is equal to the exponent n. And remember, you cannot put this in the calculator until you do the change of base formula. So it's easy to remember, this is how I say it, log of big number 37 over log of little number, the base 7. Okay, and that's going to get me, the calculator, if I put it in, 1.86. so I'm going to round it to 1.86. Possible solution, right? Let's plug him in right here. And you know how we simplified? You can use the simplified equation. It makes your life a little bit easier. So let's plug him in. 7 to the power of 1.86, because that's my n, that's what we're saying n is. Does that give me close to the number 37? And if you put in the calculator, you'll know that yes, it does. Therefore, I could say 1.86 is a solution. So you always have to check, okay? Always check. Okay, let's move on to the next. Let's do number 7. So remember, simplest form. Do you guys see that 7 in front right here? Let's get rid of him. So this is a positive 7. So to get rid of that 7, we have to subtract 7 to both sides. So that leaves me with negative 4x plus 1 is equal to 18 minus 7, which gives me 11. Let's also get rid of that negative in front of the 4, right? That's technically a negative 1 multiplied in front of the 4. So let's do opposite. You could either multiply or divide negative 1 to both sides to get rid of that negative in front of the 4. So that makes the 11 on the other side a negative 11 when you divide by negative 1. Okay, now it's in its simplest form, right? Now let's go ahead and change it to a log. Log base 4, right? That's my base of the other number on the other side, negative 11. Again, I'm going to put that in parentheses. Is equal to the exponent, x plus 1. Okay, remember what I said. I've said this before. Logs can't be negative. Logs cannot be negative. Do you guys see that the number inside the log is a negative 11? It's impossible. If you try, say you forgot, and you try using your change of base formula, and you say, okay, log of big number over log of little number, and you try putting that in the calculator, it gives you an error. It is impossible for logs to be negative. So instead, we're going to say that this is a no solution. Why? Because logs cannot be negative. Okay, so make sure you write that down. Make sure you remember that. Okay, let's try one more. I'm going to skip 9 and I'm going to jump to number 11. Let's try number 11. Actually, let's go down to number 13. Yeah, this is a better one. Okay, let's simplify this, right? To simplify an equation, remember, you add and subtract first, then you multiply or divide last. So, in this case, to simplify this equation, order does matter. Add or subtract first. In this case, I'm going to add 2 to both sides because that's opposite of that minus 2 to get rid of it. So add or subtract first. So let me bring everything else down. And 82 plus 2 gives me 84. Then I can divide. So you multiply and divide last. So I'll divide by that 6 to get rid of it, because I'm trying to get this in its simplest exponential form. And 84 divided by 6 gives me 14. Okay, now that I have this in the most simplified form, now let's change it to a log. So log, the base here is 16, the number on the other side of the equal sign is the 14, and the exponent is 7y plus 2. Okay, let's use our change of base formula. So log of big number, log of 14 over log of 16 is equal to 7y plus 2. Okay, in the calculator, when you put that in, that gives you 0.9518, or let's just say 0.95, is equal to 7y plus 2. Okay, let's solve for y. Remember, subtract first, add or subtract first. So that's going to give me negative 1.0, let's just round it to 0.5, is equal to 7y, and then we can divide last. So I'm going to say my solution, possible solution, is negative 0.149, round, negative 0.15. Okay, possible, let's check it. Even though our solution is negative, that's okay. Is it in a log? No, this is a possible solution. It could be negative. The only time that it cannot be negative is when it's literally, let me show you back up here, when it's literally inside the log. Do you see how the negative 11 is inside the log? That's when you say no solution. but a solution can be negative, okay? All right, let's check this. Let's plug it back into the, not the original, let's do the simplified. Remember when we simplified our exponential equation up there? So let's plug in, so we're looking for negative 0.15. We want to see if that's truly a solution. So I'm going to plug 0, negative 0 point, was it 15? Yes. Negative 0.15 plus 2. And I want to see, I'm going to put that in the calculator, I want to see, does that give me about 14, the number 14? So plug that in the calculator. And yes, it gets me close to the number 14. Therefore, I could say this is truly, negative 0.15 is truly a solution.